In this video, we'll discuss ways to determine whether a function is odd or even or neither. Here I have a function graph, f of x equals x squared minus 4. To determine if this is an odd or even function, we can evaluate the function at negative x. In other words, replace each of the x's in the function with a negative x and then simplify. In this case, negative x times negative x is positive x squared minus 4. That's the exact same expression that we started with, and because of that, we call this an even function. If you notice that for any positive value, let's say a positive 3, we have the exact same value as negative 3. Also notice that an even function reflects across the y-axis. So we have an algebraic way of determining whether or not we have an even or an odd function, and we have a visual way from the graph. Let's look at a second example. The function g of x equals x cubed minus 4x, and once again I will replace each of the x's with a negative x, evaluating g of x at a negative x. Let me simplify. A negative x quantity cubed is negative x cubed. Negative 4x times negative x is positive 4x. And if I compare that to the original function, you'll notice that each of the signs is the opposite of what it was before. So we have g of x is equal to the opposite of g of x. In this case, we call the function odd. What that means is, for some value of x, let's say 1, it has the opposite y value that negative 1 has. That causes rotation around the origin, so visually we can see if a function is odd or even by seeing if it rotates about the origin. Algebraically, we use the same test that we used for the even function, plug in negative x for all the x's. For an even function, if the function at the negative x is the same as the original function, it's even. If it's the opposite of the original function, then it's odd. Let's look at another example. Let's evaluate h of x, or evaluate the function h at negative x, replacing all the x's with a negative x. Simplify. Negative x quantity cubed is negative x cubed. Negative x quantity squared is x squared, so we have plus x squared. Negative 3 times negative x is positive 3x plus 2. If I compare this function with the original, we'll see that sometimes the signs are opposite, sometimes the signs are the same. In this case, we say the function is neither even nor odd. Notice that we do not have reflection across the y-axis, and we do not have rotation about the origin. So again, visually we can see it's not even or odd. Algebraically we can see that too. Now each of these examples was a polynomial. And with polynomials we have one more key that we can look at. If you look just at the exponents, in this example, I'll write down x to the 0 for 2, 2x to the 0. In this example, I had a mixture of even and odd exponents. But in the other examples, in this first example, if I think of x to the 4th or 4 as 4x to the 0, both of my exponents were even, and the function was even. In the other example, both of my exponents were odd, x cubed and x to the 1st. So looking at the function, if it's a polynomial, if we have all even exponents, the function's even. If they're all odd, it's odd. If we have a mixture, it's neither even nor odd. Let me give you a problem to try on your own. Pause the video, determine whether this is even or odd. visually from the exponents, visually from the graph, and also perform the algebraic process of substituting negative x for the x in the function, and come back to the video when you want to check your answer. Algebraically, if we replace all the x's with negative x, and simplify, a negative x quantity to the fourth is x to the fourth. Negative x quantity squared is x squared, so we have minus 6x squared plus 2. I have the exact same expression that I started with, so this must be an even function. If I look at the exponents, they're all even, thinking of 2 as 2x to the 0 power. They're all even, so the function's even. Also, it looks like we have reflection about the y-axis, also telling us that it's even. So those are the three ways that you can tell if a function's even or odd. Sometimes the graph may be deceptive, so be careful of that. But algebraically, we can substitute negative x for x, determine if the function is exactly the same as what we started with, or if it's opposite, or neither. Look at the exponents, determine if they're all even, or if they're all odd, or if there's a mixture. Or see if we have a rotation about the origin or reflection about the y-axis.